future. And one more click. The hard part is the transformation. We don't have the arrows, the technologies for the arrows. Another click. One more, yes. And one more. Deploying these on a large scale will require huge physical resources. And that in turn will require new ways to make things. New technologies and much larger scale and lower cost. So next. The UN has set a series of Millennium Development Goals, eradicating poverty and hunger, universal education, and so on. And I would just like to look at these in sequence and discuss how advanced nanotechnologies can address some of these problems directly, solve some problems, and create a changed environment for work on the other problems, indicating its importance to this full spectrum of problems. So the next slide. The most direct application of new productive technologies is to providing human needs in a way that is sustainable and inexpensive. So eradicating extreme poverty and hunger, the first on the list. Then we see ensuring environmental sustainability. Both of those would be very direct consequences, very direct applications of better ways of making things. Next. 3 more goals are medical in nature, reducing child mortality, improving maternal health, and combating various diseases, HIV, malaria, and so on. All of those can be addressed if we have better ways of making things, better ways of making not only conventional medicines at lower cost and superior ones, but making the devices necessary for new kinds of medical therapies, new ways of attacking disease organisms, new ways of stimulating the growth of new healthy tissue to heal injuries, and so on. So that range of products can address this set of goals. Next. Now, these are further from a direct application, but a revolution at the scale of the Industrial Revolution or the Digital Revolution will change the world, and therefore will change the nature of these problems. It will change the context in which people address these problems. And the 2 listed here are universal primary education and promoting gender equality and empowerment for women. The Industrial Revolution has made an enormous difference to the labor that must be performed in the world, and has certainly changed the status of women, and has also made education more available by reducing the need for children to work. So there are strong relationships between these changes in technology and these goals as well in economic and social change. And the final goal, one more click, is to develop a global partnership for development. And from what I can see of the prospects of future technology, perhaps the most important, the highest leverage, the overwhelmingly effective change looking forward into the century for economic development and human development will be this next technological revolution. Will be the development of new ways of making things, new products, new cost, environmentally sustainable, and so on. If we achieve that, the world will be a different place, and these enormous problems, these enormous hopes for humanity can be addressed in a new way, and I believe more successfully. To do that well will require a global partnership. If any single country were to lead in this area, I believe that would be a problem. It would be destabilizing. It would lead to a future that I would not want to see, and I think many other people would not want to see. So a joint effort, a global partnership for technology development, is something that I believe will lead to a better outcome and will lead to progress in solving world problems at an earlier date and with great benefits. to the human race. So, one more click. Next slide. This just shows that there's nothing small about nanotechnology. The scale of applications and transformation is in fact global. Thank you for your time and attention. And I understand there may be some questions.
Good afternoon, Dr. Drexler. At the beginning of your dissertation, you thought that we can simulate in laboratory the elements of nanotechnology, and the goal for the future is to build some task elements. Exist in nature whenever or what elements that we can observe and have a similar effects or similar outputs to those machines that we at present are planning to build, please?
Yes, the ability to use understood physical principles and computational methods to simulate such simple things as molecules, and to use engineering modeling techniques to describe larger systems, to use engineering design system capabilities and systems to model even larger and more complex systems is a very advanced technology today that is applicable to understanding the physical basis, the physical structures, the physical capabilities of these advanced technologies. Looking forward to their applications in transforming the world, however, it would be very desirable to understand the consequences of these developments, to understand what choices people can make that would lead to ethical outcomes, to a higher quality of life and solution of human problems when new technologies, as always, will also be able to create new problems. In particular, new ways in which people can dominate other people, the problem of political control, the problem of military balance of power. And those political and ethical problems are, of course, far more difficult. There has been some thinking about those. I would like to see, in the coming years, as soon as possible, an understanding of the physical basis leading to a wider global discussion of the significance of these developments and a better understanding of